I think to begin this problem, I need to remind you that the segment, the triangle segment that is across from the shortest or the smallest angle will be the shortest, okay? So anytime you have the smallest angle will be directly across from the shortest segment. All right, let's figure out what we know here. First of all, do you know the big triangle, triangle FGH? Do you see that we could figure out what this little missing piece is because we have all the other measurements. So we know that angle F is 70. We know that angle H altogether is going to be 55. And we know that part of angle G is 30, right? So if we know all of that information, that plus angle JGH, I'll just mark that angle JGH has to add up to 180 degrees, okay? So that is how, if you do the math on all of that, you will discover that this is equal to 25 degrees, all right? So that's some useful information. Now, the next thing we need to do is the little triangle here. Can we figure out what those dimensions are? Well, if we know this little piece is 30, right? This little piece is 30. This is 25. That makes 55, which means if you do a little bit of math on that, if you take 180 minus 25 minus 30, that will give you, that's equal to 125. 125 is this dimension right here. Okay, now we're ready to start evaluating. Across from which angle is the shortest side? Well, the 25-degree angle is, there's a 25-degree angle here, but that's only part of it, right? So this is actually the smallest angle, which makes side JH the shortest line segment.